Tour de force. All over the world, the great cities are distinguished by their architecture. Paris has the Eiffel Tower, New York, the Empire State Building, and Toronto, the CN Tower. As one of the great cities of the world, Halifax needs such a distinction. You may have heard discussion regarding the Halifax skyline and how it should not be obstructed, but think how beautiful the skyline will be with a tower built by robots flying high into the sky.
Now that we've got all the details worked out, how are we going to build the tower?
We'll need a machine, one that's strong, agile,
and cool looking, of course.
Sounds like a job for Baratbot!
Maybe not.
No, she can do it. We just need to help her along a bit.
Yeah, it'll be like Extreme Makeover, Robot Edition. Last year when it came to attaching and powering an arm, our first idea was to use the drills to power both the wheels and the arm. Unfortunately, our attempt at doing this was unsuccessful, as we found that using such a system was too complicated. Using this method, the arm would not go consistently up and down, and we found that there was no way of engaging the arm independently. Instead, we decided to use a trap and drag device rather than an arm as shown here. While this worked for the 2005 last-ditch effort competition, it was apparent that because of the requirements of this year's competition, our robot would have to have an arm or lifting device. Baratbot 2005 was composed of 2 levels. Last year we found it very difficult to adjust the torque of the drill on the lower tier. In order to allow for better access, we sawed off the platform. However, this year we planned to have a completely different frame to allow for further access. The wheels were indirectly powered by the drills using belts. Aligning the belts to prevent the shafts from sliding in and out was a concern. Both Baratbots 2004 and 2005 were built of perforated plywood frame. This made it difficult to correct or modify the body of the robot because mounting and removing objects from the robot left permanent damage. This year we are planning on replacing this with the metal frame. Baratbot 2005 employed tank steering using both joysticks on the control device. This made it difficult for the driver to orient themselves in relation to the robot, thus causing difficulties in steering. Furthermore, the technical limitations of the transmitter added difficulty to the steering process. For example, the left joystick did not always go into neutral, and the robot was much too sensitive to the signals transmitted by the crystal. This year, the controls for both driving wheels of the robot were transmitted to one joystick on the control device, while the other joystick controlled the servo motor. This made coordinating the robot easier. Baratbot 2005 consisted of a 2-tier plywood frame onto which the drills, wheels, servo motors, etc. were attached. As discussed earlier, we did not find this sort of frame to be ideal. We found the metal frame of an old robot used in 1998. This frame turned out to have the ideal shape for the type of robot we were envisioning. After modeling this frame on the Solid Edge computer program, we were able to further design our robot, virtually mounting the wheels, drills, and end effector. Using these designs, we were able to build the final robot. Deciding on a system that would efficiently power an end effector proved difficult. Initially, we envisioned a clutch system using drills that would power an arm and a gripper. This would enable us to quickly raise and lower the arm and use a servo motor to open and close a gripper. This system, however, was time-consuming and difficult. Our next idea was to use traditional drill power for the wheels and to use one servo motor to raise the arm and the other servo motor to open and close the gripper. Calculations showed that we had insufficient drill power to lift and move the heavier objects without using gears. Instead of an arm, our mentor suggested using a lift system. One servo motor would raise the lift and the other would control a gripper. The gripper would pivot at the top of a crossbar. Like the arm, we also had to design a gear system that would operate the lift. Using these ideas, we drew up the final plans for our elevator lift and designed general dimensions for the placement of the grippers and for the size of the grippers themselves using the Solid Edge computer program. Our strategy is designed to get maximum height from a minimum number of pieces in order to be most efficient. The elevator system we chose allows us to build the tower without going up the ramp onto the starting block, and our end effector allows us to both lift and grab pieces. With her agility, speed, and power, Baratbot is ready to play.